Good morning, everyone. So, dear students, let's start with the next part of the mensuration chapter. So, in the last video, I had explained you about the introduction. I had given an introduction about the difference between perimeter and area, the difference between perimeter, area, and different types of polygons. What are polygons? Different types of polygons, starting with the triangle, quadrilateral, pentagon, hexagon, septagon, octagon, nanogon, and decagon. So I had explained about these things, and now I am moving to solve the three problems of this try these of mensuration chapter. Okay, so let's start with the first problem. Divide the following polygons, that is these two polygons, into parts, that is into triangles and trapezium, to find out its area. So we have to find out the area of this polygon. It's a polygon having how many sides? 1, 2, 3, 4, 5 sides. That means this polygon is a pentagon. So we have to find the area of this polygon by dividing it into parts. They have told to divide them into triangles as well as trapeziums in order to find out its area. So as you can see in this picture, they have already drawn Fi as the diagonal of the polygon EFGHI. So they have given here Fi is a diagonal of polygon EFGHI. Now since they have drawn a diagonal, so this polygon is being divided into a triangle and one more polygon, right? So you can easily find out the area of this triangle EFI, and then for this polygon you can divide it into a triangle by drawing a perpendicular from G to say M and find the area of this triangle, and again draw a perpendicular from H to this Fi with a point on Fi, so that these two lines become perpendiculars, and this part it will form a trapezium, and the remaining this part again you will get a triangle. So I'll explain to you in detail by drawing the picture, by drawing perpendiculars. So let me draw the polygon. See, this is the polygon that they have given. So the polygon that they have given is EFGHI. You have to find the area of this polygon or this pentagon. Why am I calling this as a pentagon? Because it is having 5 sides: EF, FG, GH, HI, IE. 1, 2, 3, 4, 5 sides. Therefore, it is a polygon of 5 sides. You can also call it as pentagon. So now they have already drawn a diagonal Fi. So this diagonal is dividing this pentagon into a triangle as well as one more quadrilateral, GFIH. Okay, now I will show you how to find the area. Now see, the area of this polygon is nothing but the area of this triangle FEI, this triangle, as well as the area of this quadrilateral. We can easily find the area of this triangle, because you know the area of the triangle formula, half into base into height. In this problem they have not given you the exact measurements, just they have told you to solve how you are going to solve this problem, not by giving exact measurements but just by telling how you can solve this. So you can solve this by first finding the area of this triangle FEI, that is half into base into height. of this triangle, and then the remaining this quadrilateral HGFI is the quadrilateral. Now how to find the area of this quadrilateral? I'll show you how. See, what you have to do is from point G you have to draw a perpendicular line to FI. You have to draw a perpendicular from G to FI. So when you draw a perpendicular, this forms a triangle. Say this point is say M. So this becomes a triangle. Now you can find the area of this triangle again by the formula half into base into height. Then here again you have to draw one more perpendicular from H to Fi, say at a point N. HN is perpendicular to Fi as well as GM is perpendicular to Fi. So now this quadrilateral again is divided into one triangle here, one more triangle here, and then the remaining portion, this part HDMN, it becomes a trapezium. How it becomes a trapezium? Because it has, this quadrilateral has one pair of parallel lines. See, GM is parallel to HN. So this HGMNH, it becomes a trapezium since these two become the parallel sides. What is a trapezium? Which has a pair of parallel lines, and the remaining two sides, they are called the legs. So this is forming a trapezium, and you know the formula how to find the area of a trapezium. So we can easily find the area of this polygon by finding the area of this triangle first. Then the remaining quadrilateral, again I am dividing it into two triangles and a trapezium by drawing perpendiculars to the diagonal. When I draw two perpendiculars, so this portion or this quadrilateral again is divided into triangle, this triangle as well as this triangle, and the remaining part, it becomes a trapezium. So the total area of this polygon is the area that you get by adding the area of this triangle, this triangle, this triangle, as well as the area of this trapezium. Okay, in problems, in further problems, what they will give? They will give the measurements of the sides, and by putting those measurements in your formulas, you can find the area of the parallelogram, area of the polygon. Okay, now let me just tell you by writing the formulas and telling you how to find the total area of this polygon. See here, I'll write it here. First, area of polygon is equal to, see this triangle, area of triangle FEI plus area of triangle GFM plus area of triangle HNI plus area of this trapezium, area of trapezium GMNH. So what is the area of triangle FEI? Area of triangle FEI is equal to, FEI is half into base into height. That is half into, what is the base? Fi into height is what? When you want the height of this triangle, you have to draw a perpendicular from E to Fi. When you consider this triangle, in order to get the height, you have to draw a perpendicular from E to Fi. So what is the area? Half into base. Base is Fi, this line segment Fi, into height. Height is, say, EO. Okay. Next, area of triangle GFM. Triangle GFM. Again it is half into base into height. Half into base is what? FM. Into height is what? GM. Similarly, area of triangle HNI. It is half into base into height. Half into, what is the base? Ni. Height is HN. Understood? Next is area of this trapezium now. Area of trapezium GMNH. It is nothing but half into height into A plus B. The formula of finding the area of a trapezium. Half into height into A plus B, where A and B are what? They are the parallel sides. Parallel sides. The parallel sides of this trapezium are GM and HN. These are the two parallel sides. And height is what? Height of the trapezium is, see, when you consider this as a trapezium in this way, this is the trapezium and height is this only. The distance between the two parallel sides, MN, is the height. Got it? This is the trapezium. Okay. What is the height? Is the perpendicular distance only between the two, is the height. So Mn itself becomes the height of this trapezium. So I can write it as half into height is Mn into A plus B is the sum of the parallel sides. Sum of the parallel sides is, what are the two parallel sides? GM plus HN. GM plus HN. So by adding all this, you will get the area of the polygon. So when they give you the exact values of the sides, different sides of the polygon, you can find the exact area of the polygon. So this is generally that they have given you in order for you to know how to find the area of a different types of polygons. They have just given you the sides, but they have not given you the exact values. Okay. In further problems, what they will give you the measurements of the different kinds of sides, different sides. Then you have to put those values and find out the total area of the polygon. Understood? So let's move on to the next polygon. So the next polygon they have given is this figure. How many sides? 1, 2, 3, 4, 5, 6 sides. So this is a hexagon. 1, 2, 3, 4, 5, 6 sides they have given. So this polygon is a hexagon. When it has 6 sides, you call that polygon as a hexagon. Here they also have given NQ is the diagonal of polygon. MNOPQR. NQ is the diagonal. So see in this figure, you can find the area of this polygon by dividing them into triangles and trapeziums in the same way as you have done for this. Okay, you can draw perpendiculars from O to NQ. Again from P to, at some point P to NQ. Then you will get a triangle here. Again a triangle here. And then the middle part will become a trapezium. In the same way here also, from M to N draw a perpendicular. From R to NQ again you have to draw a perpendicular. This portion also gets divided into, again now, one more triangle here, one more triangle here, and the remaining center part will form a trapezium. So you will have here 1, 2, 3, 4, 5, 6 areas. Okay, so I will explain to you by drawing the picture in detail for you and how to draw the perpendiculars and all. So let's move to the in detail drawing of the pictures. So let me draw this picture for you, plain polygon, and solve it. M N O P Q R, and this is the diagonal that they have drawn, NQ. So now what you have to do, from this O you have to draw a perpendicular to NQ. Again from P you have to draw a perpendicular to NQ. Okay, you name this as points A, point B. And then from here also you can draw a perpendicular. You name them as some other points like A, B, C, D. So the area of this hexagon will be the area of the triangle NCO, area of triangle PBQ, area of triangle NAM, area of triangle QRD, 4 triangles, plus the area of these two trapeziums, trapezium OCBP and trapezium AMRD. Did you get this? So the total area of the polygon is the area of these 4 triangles as well as the area of these 2 trapeziums. In the same way what I did in the last problem. You have to put the formulas for the areas of the trapezium. You have to put the area formulas to find the areas of these 4 triangles. That's it. Understood? If you have any doubts, you can please comment me in this section. And please do subscribe my channel. So let's now move on to the next problem. In the next problem, they have given you values of the different values of the sides. See here. Let me read you the question. Polygon ABCDE, polygon ABCDE is divided into parts as shown below, figure 9.4. Find its area if AD is 8 cm, AH is 6 cm, AG is 4 cm, AF is 3 cm, and BF 2 cm, CH 3 cm, EG 2.5 cm, EG. So as I had told you in the previous problems, they have drawn perpendiculars and they have given the measurements of the perpendiculars as well as the different values of the sides. So you can easily find the area of the polygon. See here, in this polygon you get one triangle here, one more triangle here, one more triangle here, one more triangle here, and the remaining is the area of the trapezium. When you find the sum of all this, you will get the area of the polygon. It's very easy. So let me do this problem to you. Let me draw the picture. B, C, A, E, D. A, B, C, D, E, and this is the diagonal AD. Okay, and they have drawn a perpendicular from here, again a perpendicular G. Okay, so let me find the area. First let us take this triangle. Now see, they have given AD as 8 centimeter. If this is 8 centimeter, and next AH they have given as 6 centimeters. AD is 8, AH is 6, means what is HD? 8 minus 6. So HD is 2. AD total is 8 centimeter and they have told AH is 6 centimeter. So what is the remaining part? 8 minus 6. AD minus AH. 8 minus 6 will give you HD. So HD is 2 centimeter. Then they have given AG as 4 centimeter. AG 4 centimeter. AG is 4 centimeter. So if this is 4 centimeter, AG is 4 centimeter, then GD is again 4 centimeter. Because AD is 8 centimeter. AG is 4 centimeter. AD is 8 centimeter. That means GD is 4 centimeter. If GD is 4 centimeter, we have got HD as 2 centimeter. Then this remaining GH is again 2 centimeter. Did you get what I am telling? AD 8 centimeter, AH 6 centimeter they told. So HD is 2 centimeter because 8 minus 6 will give you 2. Now they have told AG is 4 centimeter. AG 4 centimeter means GD is 4 centimeter because they have already told total AD is 8 centimeter. 8 minus AG, 8 minus 4 will give you the remaining GD as 4 centimeter. Now we have found out already that HD is 2 centimeter. If this is total 4 centimeter and this is 2 centimeter, remaining this part is 2 centimeter. Understood? Now next they have told AF is 3 centimeter. AF is 3 centimeter. They have told that AG is 4 centimeter and now they are telling AF is 3 centimeter. Then what is this remaining FG? Yes, it is 4 minus 3, 1 centimeter. It is 1 centimeter. Now you calculate total AD in order to cross check. AD is AF plus FG plus FH plus HD. That is 3 plus 1, 4. 4 plus 2, 6. 6 plus 2 again 8 centimeter. So whatever calculations we have done is correct. Total we are getting 8 centimeter. Understood this? Next, they have told BF perpendicular is 2 centimeter and then CH, that is also 2 centimeter, and EG perpendicular, it is 2.5. Okay, now let's start with the area of triangle AFB. Next, BCFH trapezium, and then CHD triangle. Similarly, area of triangle ADE, whole this triangle. So you'll get the total area of the polygon. So let us do, I'll work it out and show you. First start with the area of triangle AFB. It is what? Half into base into height. Nothing but half into base 3 into height is what? 2. this two gets cancelled. It is 3 centimeter square. Okay, so I found out the area of this triangle AFB. Next, let's move with the trapezium FPCH. Area of trapezium FBCH. What is the area of trapezium formula? Half into height into A plus B, where A and B are the two parallel sides and H is the height. So what is that? Half into, what is the height of this trapezium now? BF and CH are the two parallel sides. What is the height in between these two? So the distance is the between these two parallel sides is FH. So this FH becomes the height. What it is? 1 plus 2, 3 centimeter into A plus B. A plus B is the sum of the parallel sides. Sum of the parallel sides is BF is one of the parallel side and CH is one of the parallel sides. It is 2 plus 2. So half into 2 plus 2 is 4. 4 3s are 12. 2 1s are 2 6 are. So it is 6 centimeter square. Area of triangle AFP is 3 centimeter square. Area of trapezium is 6 centimeter square. This and this are over now. Now find the area of this triangle. Area triangle CHD. Area of triangle CHD is half into base into height. Half into base is what? 2. Into height is what? 2. 1 2 gets cancelled. Again it is 2 centimeter square. So area of triangle AFB is 3 centimeter square. Area of trapezium is 6 centimeter square. Area of triangle is 2 centimeter square. Now the remaining is area of the triangle AED. What is the area of triangle AED? So see here, area of triangle AED is nothing but half into base into height. Same thing. Half into what is the base? AD is the base. AD is the base and height is EG. Base is how much? 3 plus 1 plus 2 plus 2. That is AD. AD they have given as 8 centimeters. Into height is 2.5. EG is the height since it is a perpendicular drawn from E to G. What it is? 2 1s are 2 4s are 4 into 2.5. 4 into 2.5, how much it is? Calculate it. It is how much? 10 centimeter square. So what is the total area of the polygon now? 3 centimeter square plus 6 centimeter square plus 2 centimeter square plus 10 centimeter square. So the total area of the polygon AEDCB is how much? 3 centimeter square. 3 plus 6 plus 2 plus 10. What's the value? How much you get? Total 21 centimeter square. is the answer. Did you get this? Did you understand the explanation? So the next problem I am going to do it in the next following video. Do subscribe my channel.